hard at all. But before we do the test, we have to talk about what is a series. A series is the summation of terms in a sequence. Okay, we're exploring new ground here, huh?
No, let me just turn down. It's a little cold. There.
That's okay. Series is a summation. Adding summation of terms, those were the y values, in a sequence. And from here on out, 11.2, 11.3, 11.4, 11.5, 11.6, we're just going to look at series. You go, how do we determine whether those converge or diverge? We're just going to be adding numbers, right? We want to know you keep adding the numbers. If you converge to a number, it's just going to explode towards infinity. So we use specific tests to this. First of all, we've got to talk about the notation. And when we use the Greek symbol sigma to represent summation. And they'll give the index here, maybe started at a 1, and head towards infinity. Well, before we head towards infinity, can I just put like a 4 here? And I'm going to make up a series. How about 2n plus 1? And can you just help me add up this tiny little, that's a finite series right there. There are how many terms in this series? I'm going to plug in a 1. I'm going to go by ones, and I'm going to stop at what number? 4. And I'm going to plug it in, and I'm going to get 4 terms to pop up, and what will I do with the 4 terms? I'm add them up. Let's just see. So right now, we're just getting our hands dirty, right? What is a series? We say a series is a summation of terms in a sequence. That's the notation. So every time you see that funny looking sigma there, you're like, oh, sum. Different from, these are what? Sequences, right? Oh, there's the sequence. I see it. See the sequence? Now we're summing up the terms of the sequence. Well, in this case, how many of them? Just 4. So when plug a 1 in there, what do you get?
3.
Right? Plus, now plug a 2 in there.
5.
Plus,
7.
when do I stop? Well, they said stop at the 4th one. First, plug in a sub 1. So this was really, that was a sub 1, that was a sub 2, that was a sub 3, and this is a sub 4 like we talked about, you know, in the previous section 11.1. What's the sum though? 8 plus 7 is 15 and 9 is 20. You go, yeah, but that's a pre-calc problem, right? What are we looking at in our section? Well, pretty much every problem. Guess where we're heading towards? We want to know, are the series convergent or divergent? So the first type we talk about, and this is what we're doing in our problems. By the way, I think a lot of you know what's happening with this one. Did you just tell me your hunch? 4 terms add up to 24. They keep getting bigger. The sum would keep getting bigger. What do you think that's doing? That series is headed towards infinity. This would be a divergent series. So they still use those same words, divergent and convergent. Is the series convergent or divergent? Well, the first type we're going to talk about, everyone, is a geometric series. A geometric series is adding up the terms of a geometric sequence. So, what's a geometric sequence? A geometric sequence. You bet I could have talked about this in 11.1, but I didn't feel the need. I said, why don't we talk about it right now? I'm putting the word sequence. It's a very, very special type of sequence. You know all the terms? There's a common ratio between consecutive terms. So we got to understand that definition. A geometric sequence has a common ratio between consecutive terms. That's its definition. And what's so cool, if we recognize this, you and I can always use the geometric series test. All right, well, here's an example. 2, 6, 18, 54, and I'll put a comma and put dot, dot, dot. It's funny, when you write sequences, we just put commas. We just put commas between the terms. Series, we put the pluses, right? So no series yet, but everyone, would you look at the ratio? Now, when I have a ratio, I don't want you to do this, divide this. Could you take the one afterwards and divide the one before? So what's the ratio? What's 6 over 2? Okay, what's 18 over 6? And what's 54? So for your notes, you're like, that's a geometric sequence right there. There's a common ratio between terms. What is the common ratio? The common ratio is a 3. Now, some students look at this easier and they go, they're like, duh, it keeps multiplying to 3, right? That's your ratio. If you can figure out the number that just keeps multiplying the second to the previous term, that's your ratio. Multiply to 3. I multiply to 3, I multiply to 3, but it consecutively does this. That's called a geometric sequence. Let me go there. Now, can they alternate? Yes. So I'm going to give you an example. But if this was negative, this was positive. This was negative. Well, what's the ratios? Is this a geometric sequence? What's negative 6 over 2? Okay. What's 18 over negative 6? What's a 54 that's negative over a positive 18? So I didn't want you to think, oh, I see that negative 1 to the nth thing that they got, so it must not be geometric. Oh yeah, geometric sequences can have a negative 1 to the nth. It's just going to alternate, which means all the ratios will still be negatives. Cool. Now what's important to us, we need to be able to recognize geometric sequences in this format. Okay? So now I'm adding a what? That's a series, right? So can you look at this next sequence? Right, so that was a geometric sequence, right? Common ratio between terms. What's the ratio? Negative 3, how do you find it? Be careful. It could throw off your entire problem. When I find a ratio, did I do this, divide this? Take the second one and divide the first one. You follow me? And we're going to call that the letter R. You notice there's a math form over here in a second that we're going to use. See that R for ratio? All right. Well, we need to be able to recognize geometric series. So I'm going to give you another example, a very simple example. There's a very simple example of a geometric sequence. Does everyone see that? 2, 4, 8, 16. Can you find that common ratio? 2. It keeps multiplying to what? A 2. Do you agree? 2 times 2. What's 4 to? Here, I'll write it out. What's 4 over 2? What's 8 over 4? This had nothing to do with the first term being a 2. It's just that the common ratio was 1. Common ratio between terms. So, do you know what this would look like in a series? 2 to the n. So, I want everyone in here to be able to recognize geometric sequences in series. By this, they're exponential. I should say that 5 times. How can you recognize something that's geometric? The exponential expression. 2 to the what? Nth. Or Katie, it could be 3 to the n. Or it could be negative 1 to the n over e to the 3n. But it's exponential. So they call it geometric. My goodness, they should have used what word? They should have called these what type? Exponential, like exponential sequences, right? That's what those dots are doing. When you keep multiplying this. That's a geometric sequence. This is the summation of terms in a geometric sequence. So what do they call this? They call this a geometric series. This, with the summation, is a what? A geometric series. So the word series means sum, right? You might as well say this word series. Whenever I see it, they're talking about a what? A summation, adding terms. So you go, well, we just talked about a geometric sequence. What's a geometric series? The summation of terms in a geometric sequence. Okay, so I'll erase all this. I'm going to leave that out. This is so awesome. There's something called a geometric series test. So our first test. This is the only test where we know whether or not it can converge to an exact number. The other ones we'll just know whether they converge or diverge. So we can actually find the exact number they converge to. Geometric series test, that ratio we call R. Now if the absolute value of R is less than 1, the geometric series will actually converge to a number. And it converges to a math formula, first term over 1 minus ratio. You might have saw this in a pre-calc class. You might have did this in a pre-calculus class. So this might be familiar to you. You can call it a sub 1 for the first term. You might call it a sub 0 for the first term. So that's why I put it in words as well. A sub 1 being the very first term of the sequence. It converges if the absolute value of the ratio is less than what? 1. But what if the absolute value of the ratio is greater than or equal to 1? What happens to the series? It's divergent. A very simple test. Cool? So I'm curious, how about this problem? Is this series convergent or is this series divergent? It's all about the ratio. Now, I'm stuck. How do I find that ratio? It's all. First of all, you recognize that that's a geometric sequence right there. Because it's exponential, right? But you might add it up. What do you have here? I want to see. 2 to the 1 is what? 2. 2 squared, 2 cubed. But I want to look at these terms here. What's the ratio of 2 squared over 2? And what's the ratio of 2 cubed over 2 squared? 2. That's equal to a 2. That's equal to a 2. What's the ratio? This is a geometric sequence, right? But I need you to be able to recognize it. It's the exponential part. Cool. Can I just write down a few examples of some series? I'll do that in a second. But I was wondering, here's my question. Is this series convergent? If it's convergent, find the number it converges to. Or is it divergent? It's divergent because the ratio is what? This is divergent, actually going towards infinity. The ratio, the absolute value of r, is greater than or equal to 1. It's come back to what? 2. So what if you get a negative 2? You take the absolute value of it. Cool. I'm going to do that. So once everyone has this copied, I'm just going to go and do that. I'll put a little negative 1 at the end there. Ready? I'm going to do it right now. What about it? What if I had this? Negative 1 to the end. Maybe that's convergent. What's the common ratio? What happens when you plug in a 1? Negative. You plug in a 2, positive. You plug in a 3, negative 1 cubed is what? Negative. What are the common ratios? Ratio R is 2 squared over negative 2, give me just a negative 2. Or it's what? Negative 2 cubed over 2 squared? What's the absolute value of negative 2? This is also what? Divergent. But what I want you to explore is, that's a geometric series. I don't want you to, oh, the negative 1, anything that's got the exponential portion. I mean, stuff like this, look. Negative 1 to the n plus 1 over e to the 5n power. That's even. I'll put in n equals 1. I'll go towards infinity. Sometimes they start these at 0. Don't let that bug you. But I want to even that is geometric. Even that is geometric. Do you want to see why? This is equal to. I want you to see why. That's negative 1 times negative 1 to the n. That's what happened. Because that's negative 1 to the 1 times negative 1 to the n. That's e to the 5th raised to the what? To the n. So you know what you have? In this case, I'll erase all this. I just want to point out this is a geometric series. This is equal to, I can take that negative 1, stick it out in front, and I can even put that, I can't do anything else, I'll just put a negative 1 in front. You got an n equals 1, and everything is raised to what power? You see what I mean? Geometric. You can look at the ratio of the terms. You have common ratio between terms. All right, before we do problems like that, now that you could recognize them, right? Before we do some of those, we gotta just look at some numbers added up. So this is geometric, right? But if you're curious, like, I wonder if that's convergent divergent. explore it. All you gotta do is find that ratio, right? Plug it in that little math formula. First term over 1 minus ratio. I just didn't want to start with that. If you want me to come back to it later, I will. Is that series, is that convergent or is that divergent? Well, before we do that one, let's look at something like this. So this is from the textbook. This is 11.2. And this is light number 18. You know why I'm doing light number 18? I thought they made it too easy. They made them all positive. I'm gonna make it weird. I'll make them alternate. All right, how about this? 4 minus 3. Plus 9/4 minus 27 over 16. Plus dot, dot, dot. The question? Determine whether the geometric series converges or diverges. You got everyone. If it converges, you need to find the sum. If it converges, find its sum. If it converges, find its sum. You know what I love about this problem? Maybe the author's being too nice here. He just told you it's a geometric series. He didn't even make you investigate that. You follow me? You're like, wow, thank you, author. But hey, the author does that in the textbook, then I'm going to be consistent on my test. It's being pretty nice here. He didn't make you try to explore that to see if it had a common what? Ratio between numbers. Someone could just put some numbers on the board, right? But he is telling you this is a what? This is a geometric series. So we already know that. We're like, okay, thank you. But now it's all about finding the what? The ratio. And if the absolute value of the ratio is less than what? 1, it converges. What if it's greater than 1? Or greater than or equal to 1? It's divergent. So, most important, which way do I divide to find the ratio? Do I do this divide this? Then do I do that divide that?
Second by first.
Second by the first. Second divided by first is your ratio. That'll work. You could have done it here, divide this. You could have done this, divide this. Take the second, divide the first. So is that ratio? Well, it's absolute value. Is the absolute value of the ratio less than 1? Yeah. Then this thing is converging. What's it converging to? This series converges. Not only that, this is the only series test that gives you a value it converges to. The only one. What's it converging to? It's got a math formula. I'll say it with words. First term over 1 minus ratio. All right, first term. The reason I'm writing it in words first, because I don't want this a sub 1 that bugs someone. Over 1 minus r, you might think, what's the r? But that's what I mean by that. So what's the first term? Is that the first term? Where's the first term? Is it a 1? Sometimes it's a 1, but in this case it's a 1. That's your first term. 1 minus, this is where I worry on the test. Do I write 3/4 or negative 3/4?
Negative.
Yeah, the math formula says 1 minus ratio. The ratio was negative 3/4. So I'm putting 1 minus negative 3/4. Now believe it or not, everyone, you're probably quicker by hand than with that calculator. Because that's 1 plus 3/4, right? So that's 4 over
7/4.
7/4. Because that's 4/4 plus 3/4. I'm serious, you're probably quicker without the calculator. How do you divide fractions?
Flip and multiply.
Flip the bottom. I'm serious. Not that you go, I don't like fractions. You just flip that bottom and multiply it. What's 4 times 4 sevenths? And you can hit this on the calculator. If you do, be careful with the parentheses. You might want to hit that math 1 fraction button because you might get that repeating decimal, right? Math 1 fracted, but I'm telling you, you're probably quicker without the calculator. That's just 7/4. 4 divided 7/4 is 4 times 4/7. That's, whoa, my bad. I saw the eyes, but like, what did you write? That's 16/1. So. Now, when I'm curious, what if I pull out Microsoft Excel right now, and I just keep multiplying -3/4 to this number, and I control, copy, paste, make a bunch of cells? What would the sum head towards? Of all those numbers, it would head towards a what? 16/7. Does that make sense? Cool. If you like Excel, play around with it. And you can do that stuff with the calculator. It's much more fun with Excel because you can copy and paste, right? And you can just see, oh yeah, if I add up, isn't there a summation button on, who uses Microsoft Excel? Do you see this button anywhere? It means sum all the cells. And play around with it. You go, just keep multiplying a -3/4 over and over and over. It's easy to put in. And then hit that summation button, you're heading towards that. Now, what if it's like this problem? Number 17. This time, I'll make them all minus, all pluses. What do y'all think? What do y'all think?
1/3.
Determine whether the series is convergent or divergent. If it's convergent, find the sum. That's number 7. I changed it around. 17 had minuses and pluses. Not a big difference. What's that ratio? 3/4 or 4/3? Game over. Let's grade go 1 in it. This is what?
Divergent.
Yeah, it's actually heading towards infinity, isn't it? That's where it's headed. That sum is going towards infinity. All right. And when I felt 1 like number 9 was tough. So I'm going to put that in the board. This is like number 9. This stuff's so cool. I'm going to put 20. Put a summation right there. N equals 1, go towards infinity. And it's 20 over -5 to the n. I want you and I to look at this. We'll explore whether or not it's a geometric series or not.
So, will this one say if it's geometric series or not?
Great question, they don't. So there it was. The author was really nice on the last one. You're onto this, Connor. He was so nice. Thanks. He wrote geometric. Now we're left just looking at this stuff going, I don't know, is that thing geometric or not? Geometric, you can usually spot it by the exponential part. Yeah, but what about the 20? Oh, that's okay. You can have a constant multiple with it. In fact, you can take that 20, it's a constant, you can put it in front of this. Just like with integrals. Weren't integrals summations? Yeah. So you can really think of this as like, this problem is really 20 times the summation of, if you want to think of it that way. 1 over 1. What's another way to write this? I just like to give you different ways you can look at this problem. It's even that. So what's 1 to the nth power? Every time you plug in a number, 1 to a 2, 1 to a 3, 1 to a 4 will just be a 1. But you don't have to do this. The key to finding whether or not it's geometric, Connor and everyone, is that there's a common ratio between consecutive terms. I want you to spot it with your eyes though, exponential. See it? It's exponential. That's a geometric series. Now you want to check it out? Let's make sure. What's some of the terms? You plug in a 1, what do you get? I'm just exploring it now. We'll plug in a 2, what do you get? What's -5 squared?
25.
Alright, plug in a 3.
125. Or -125.
What's this divide this? What's this divide this? They will be the same ratios. Common ratio between terms. 20 over 25 divided by 20 is the same as the 20 over -125 divided by that 20 over 25. Now how do you divide fractions?
Flip and multiply.
You multiply the what? Getting canceled. What's the ratio?
Negative 1/5.
Now this is interesting. When I rewrote it in this form, the ratio was the daggone thing in the parentheses. Isn't that nice? If you can somehow rewrite the expression so everything was in the parentheses with the constant in front, you'll spot the ratio. But not many students like to do this. I will point that out. From years and years and years, some students just go, listen, I'll take my time and find that common ratio. But that's the common ratio between terms. Is that ratio less than 1? The absolute value of the ratio less than 1? I need you to explore that. Yes, the absolute value of the ratio is less than 1. This series is convergent. Well, what's it convergent to? Well, there's the ratio. Let me make sure it looks like a 5. It's negative 1/5. That ratio, the absolute value, that's less than 1. This series is convergent. Well, what's it convergent to? It's convergent to first term over 1 minus ratio. Well, what's the first term? Is that the first term? Be careful. Is 1 the first term? The first term is the number you get when you plug in a 1. Let me say that again. By this wording, first term, the a sub 1. The first term is the first number you get when you plug that number, whatever it is, right there, into this. So when that's the first term, you're the first. Oh, and be careful. Some series start with n equals 0. So the first term would be a sub 0. So maybe I shouldn't even have that 1 there. Because if the thing started with a 0, the first term is plugging in the 0 into n. What's anything to the 0 power? 1. So sometimes these series can start with n equals 0. Okay, let's find the sum. It's convergent to, first number is 20 over negative 5, and 1 minus, find my error, everyone. I hate that on a test. Anybody catch it? It's so slow.
Negative.
The ratio was not 1/5, the ratio was, so I'm going to do 1 minus negative 1. Hey, do you notice that you could have found that ratio just sitting in the parentheses? But it didn't take long to do this, did it? This divided this. Okay, let's see what you get. I just don't think you need to calculate. 1 plus 1/5 is 6/5. So when you flip a 6/5, you get what? I just don't think you need a calculator. I think you're quicker. What happened to those 5s? The answer is 20 over negative 6, or 10 over what? The series converges to that number. Pull out Microsoft Excel, add a bunch of these numbers up, you'll see. But what's as a decimal? Be careful. Negative 3.333333333. So you got to recognize that point. 3333333. Everyone know where the frac button is? Math what?
Math 1.
Math 1.
You can also set your calculator to always give you your answers in fraction all the time, so it doesn't give you decimals.
Oh, that's cool.
Go to mode, answers, it's auto, decimal, or fraction or approximation. You just choose fraction.
Sweet. Everyone, I didn't want 31 to 3 off tonight or tomorrow. What they wrote. And we got n equals 1 to infinity. You got to help me with this. How in the world are you and I going to approach a problem like this? Because Connor, sure enough, the instructor, they want to know whether or not this geometric series converges or diverges. If it converges, find the sum. The only form that has a sum is the geometric series. Well, is this daggone thing geometric? So in this time, I'm going to take this off. I'll take this off too. And in a second, I'm going to introduce the next test, which is kind of fun. Determine whether this changes. Now they just write series. what's so cool about this, we just gotta say whether or not it converges or it's divergent. Okay. Oh, this is a blast. Determine whether the series is convergent or divergent. So eventually we'll get it to like, about 6 or so tests that we'll go through. But right now, all we know is the geometric series test, right? Well, is that one geometric? It looks weird to me. It's got the 1 and the 1. Can I split this up? I want to help me look at, let's explore that. Can I break that thing up? That's 1/3 to the 1. And what's that second part? Can I think of the problem like this? Is this a geometric series? Are both of those exponential? Sure, they just got different ratios. But they're both geometric series. If I split this thing up. Cool. By the way, what's another way you can write that? If you wanted to, what's another way to write that? 1/3 if you want to. If you were trying to get the ratio, guess what the ratio would be? 1/3. What's another way you can write that if you wanted to? Anybody know what the common ratio is? Anybody know what the common ratio of that one is? 2/3. What's the ratio here? 1/3. Are both of these geometric series? So when you add a convergent geometric series, one ratio is 1/3, one ratio is 2/3, they're both less than 1. If you add a convergent series to another convergent series, then the final thing has to converge. Do you agree? The overall sum has to converge. This is convergent, because that's a convergent series, and that's a convergent series. They're both geometric series when I'm looking at these individually. What's that common ratio? So by geometric series test, and by the geometric series test, that ratio was less than what? 1, you see it? And what's this ratio? That absolute value, that ratio was less than 1. It converges by the geometric series test. So here I am, I'm starting to abbreviate. Con, you were asking me earlier about like what I should write down. We at least got to explain the test we're using.
Cool. So it converges at
Oh, if you want to find, but they didn't ask it that. I love it. He's going well beyond the problem. He's like, I can find the number it converges to. Now the questions from here on out are going to be on Monday. They just want you to know whether it converges or diverges. If you wanted to, you could find it. It'd be that number's sum. You'd have to do the first term 1 minus ratio and get that one first term 1 minus ratio and add them together. But from here on out, now they're like, okay, just tell me whether it converges or diverges. But we spotted this was what? Geometric. Cool. Oh, go ahead.
If it was like 4 hands, so then the second one would have been 4/3, so the 1/3 is still converting the double diverge.
Adam, I love it. I'm glad you asked it. What if one diverges and one converges? The answer is overall just going to be divergent. So what if you had 9 converging and then a 10th one diverged? You'd have to say what? Divergent. Very good, Adam. Great question. You're saying that was a 4/3. And when this is the